Okay, so hi everyone, I'm Hideyuki Tai from NEC. Today our presentation talks about our learnings from ongoing activities to build a high available IaaS platform based on OpenStack using OpenDaylight. So since the last year, we are working towards integrating OpenDaylight into our OpenStack-based solution. So today we would like to explain about our activities to achieve this integration goal and also share some learnings from these activities in this presentation. So this is the agenda today. First of all, I would like to explain the background of our activities. And then we are going to give you some learnings from our activities with the results of our investigation, design, and development in this presentation. And finally, we would like to also discuss about the future direction of our activities, as well as the direction of the OpenDaylight project. So first, let me introduce ourselves. I'm from NEC, and NEC is an IT and network solution provider. And we have been actively working in the SDN field from the very beginning. And we released the world's first OpenFlow product, OpenFlow controller, and OpenFlow switch in 2011. And since then, we've delivered our SDN-based systems to over 600 customers all over the world. And as a founding member of the OpenDaylight project, we also have been actively working and contributing to the OpenDaylight community. So as a solution provider, we provide OpenStack-based cloud infrastructure solution. We call this service as NEC Cloud System. So this is a service which offers complete support for every aspect of cloud infrastructure, designing, building, and operating the cloud infrastructure. So based on customer requirements, we build cloud infrastructure based on OpenStack, as well as other many open source softwares. So one target use case of our solution is IaaS Platform, Infrastructure as a Service. And the current supported model of our solution is based on OpenStack, and it uses network manager available by default in OpenStack, which is OVS agent. And I mean that our solution doesn't use any SDN controllers yet. So here, as a member company of the OpenDaylight, the following question naturally come to our mind. That is, can we use OpenDaylight? Can we integrate OpenDaylight into our solution? Or does OpenDaylight bring any benefits to our IaaS platform? Actually, that was the starting point of the activities of our team, which we would like to explain in this presentation. So why do we need to work on the OpenDaylight project? So we are seeing several benefits which OpenDaylight brings for our use cases. So first of all, I think OpenDaylight would bring more flexibility in terms of what you want to build your solutions. I mean, it makes it easy to adapt new technologies, and also it makes it easy to add new network features for your use cases. So since OpenDaylight is really a good SDN platform, actually it could be the default SDN platform in the future. So I'm thinking many vendors would add new technologies or new network features on top of the SDN platform, OpenDaylight. So integrating OpenDaylight into our solution would enable to leverage such new features or new technologies into our solution. And also, we are thinking that OpenDaylight provide centralized management centralized network management. So OpenDaylight could have, OpenDaylight would enable network management integrated with underlying network. Also, OpenDaylight could have a centralized view of all your physical network devices as well as virtual network devices. So you can probably do better routing for your traffic with OpenDaylight. And also with OpenDaylight, you don't need to rely on agent-based system anymore. I mean, so for example, you don't need to care about the availability of agents such as OVS agent with OpenDaylight. So considering these benefits which OpenDaylight brings, so our team has been formed last year, and the goal of our team is to integrate OpenDaylight into our IaaS platform. So to achieve this integration goal, to achieve our goal to integrate OpenDaylight into our IaaS platform, we've done so many activities so far in the OpenDaylight community. So our activities can be divided into several phases. So investigation phase, design phase, development, and integration phase. So in the investigation phase, we investigated OpenDaylight. We investigated how OpenDaylight works with OpenStack. And we investigated how well OpenDaylight meets our requirements. And based on the result of the investigation, in the design phase, we designed the architecture in which OpenDaylight works with OpenStack well, in which OpenDaylight meets our requirements for our use case, IaaS platform. And after that, we did kind of development. I mean, we tested OpenDaylight to detect problems, to detect bugs for our use case. And also, we fixed such many problems in the OpenDaylight community. So that's overview of our activities so far. So, but that being said, actually, we have not achieved our goal yet. So we are still in the development phase. But anyway, we would like to explain our activities with our learnings from this experience in this presentation. Okay, so from this point, Venkat from HCL will talk.
Hi. Okay, I'm Venkat Rangan, so I'm reachable in IRC as GV Rangan, so I contribute to VTN and integration projects. So right now, so let me talk about the activities that our team had done towards this goal. So as Hideyuki explained, so in the investigation phase, this doesn't work, sorry. Oh. Okay, so the investigation phase, so this is where we basically started. So we had a list of requirements laid out, like this is what we expect out of OpenDaylight as a networking provider for OpenStack. So we were evaluating what is currently available in OpenDaylight and trying to see if these requirements, does OpenDaylight satisfy every one of these requirements, and this was the goal of the investigation. Basically, this is the overview what was done, and at the end of investigation, we identified where are the gaps, and then to the upstream, we started to contribute and fix those bugs and or gaps we addressed. We created enhancement bugs, and we created regular bugs, and we fixed them. So these were basically what we laid out as what is actually our requirement. So in terms of requirements, we wanted boron. We wanted to use the boron release as our official release for this particular activity, and these were the functionalities we are expecting OpenDaylight to be supporting. So basically, the first one is basic L2, L3 security group support for OpenStack, and then SNAT and support for metadata, and then VX and edge overlay, and multiple external networks and bridging multiple L2 domains. So these were the list of requirements that we wanted OpenDaylight to support to be used in our particular use case that we are targeting. And finally, of course, we wanted stable features with OpenDaylight, which anyone would require. So basically here we are trying to explain how the OpenStack and ODL integration works. So we have participated in 2 projects, VTN and Network. So from our understanding, basically all the projects that implement OpenStack integration actually implement the Neutron interface and try to handle any Neutron calls based on their own implementation. For example, VTN creates their own VTN components, so that when you actually spawn instances in OpenStack, these VTN components instead take over and they handle the networking. So the network also operates a similar way. So basically, this is the layout on various projects that are integrating with OpenStack. So here is where we tried to list what was our requirements and how different projects were supporting it. So basically, at the time of evaluation, I think the new network was something that had just started in Boron. So it was supporting most of the features that we required, but the only problem we had with that was it was a code that was newly coming in, and most of the features were not in by the time we were evaluating. So for those reasons, we had to go with the legacy network, which was already in place and was supporting partially some features that we were actually requiring. But the positive things about the legacy network were we have been testing it since the Beryllium time frame, so we definitely knew it supported clustering, and it supported L2 L3 cases, and it was fine because we also had a CSIT running, which was quite stable in terms of the legacy network. So for those reasons, we chose legacy network as our as the component that we want to use for our particular requirement. So here we have listed why we chose legacy network as a target solution. So we had a part of our support, and as I already highlighted, it doesn't support all the things that we basically required. It supported only part of it. But even still, what we understand is that the areas that it supported, it was seen to be stable. Because we had tested it in Beryllium, whereas the new network was still coming. So we had a lot of code that was freshly being added, it was not complete. So here this slide lists the functionalities or whatever features that made legacy network as our target. So basically moving on to the design phase. So here basically having chosen legacy network, we understand that legacy network comes with its own limitations. So we definitely know it doesn't support SNAT, it doesn't support multiple external networks. So what we decided is, since we want to use OpenDaylight in our use case, so we thought we would leverage what are the stable areas that is available in legacy network, and rest we will leverage what is available in OpenStack. So that was our architecture that we went with. So we will use ODL just for handling the L2 and the security groups, and for the L3 and the other features that we require, we would let OpenStack, the components in OpenStack do that for us. So this is the architecture that we planned. So here is where OpenDaylight fits in. It handles only the L2 and security groups part. For the L3 and other requirements, the Neutron L3 agent is being used. So this is our deployment. This is the architecture we chose for deployment. Yeah. Yeah, maybe we'll see how it goes. Probably there is a future direction. I mean, we are thinking, because it comes with all the features that we require. So there is a thought in that direction. So maybe after Boron SR1, maybe this needs to be discussed further.
and the legacy network has some limitation, which like he explained the limitation. But with this architecture, maybe we can meet our requirement. The legacy network meets our requirement, and also it's kind of a stable feature. So maybe in Bologna, we are thinking about using the legacy network, but in the future, for Carbon, it could be changed. Maybe we could do it.
Yeah, but ideal choice in Carbon should be to go to new network, because people are going to stop contributing to legacy network, and there are not going to be much new features that we can use. So the best choice would be to go to new network in Carbon, but not immediately, I think. Yeah.
So what features do you use OpenDaylight for versus what are outside of?
I think only the L2 and security groups. OpenDaylight just now in our deployment, it handles only the L2 networking API calls from OpenStack and security rules from OpenStack. The other L3 and other stuff is handled by Neutron L3 agent.
And those two are not covered by?
Yeah, those two are not stable because we needed SNAT and other features which was not supported in legacy network. So the Neutron L3 agent handles it. Okay. Actually, after choosing this as our deployment, we actually identified some more gaps that needed to be fixed for using this particular approach for multiple external networks and other things, so which we will probably discuss later.
So you're using the L3 agent?
Yeah. Okay. So as part of the development, so this is where it started. So with this particular deployment model, we tested all our use cases and we had multiple stages of testing. So we identified bugs as well as some functionality gaps, because having said we needed to use multiple external networks. So those use cases actually revealed new gaps, because it was not the intention with the Neutron L3 agent. Neutron L3 agent is expecting some other agent which handles the L2 part. So basically it was not built to work with ODL. So there were some other gaps that we identified. So these were the major list of development activities that we did. So
can you go on how you implemented the security?
yeah, it was already there with network. We just used it. So it does with flow entries. Okay, so I'll start with CSIT. So that was one of the first activity that we started, because we have been with OpenDaylight since Hydrogen, so we completely understand the importance of CSIT. So that is where we started. So without a stable CSIT, much of the details of the project are not known. So we started with CSIT. So what we did is we created multiple OpenStack jobs. So there was no OpenStack job in ODL Jenkins environment. So we created an OpenStack deploy job. So this deploys multiple OpenStack nodes, and it also deploys multiple ODL nodes, and the features that we require are basically tested every day. So this helps us in avoiding regression bugs and basically keeping the quality of the code. So we started with this activity. So this is one key activity that we did for Boron. So this actually helps us in multiple levels, not only for legacy network. So once we had this framework done, we did this, we added the framework as a common framework which other projects can also use. So all the projects that implemented OpenStack integration basically created a lot of OpenStack jobs. So now we are able to understand, like with GBP, what is its OpenStack integration status based on the CSIT job. So this helped us at multiple levels in making a choice whether we had to go with legacy network or new network. So this activity that we did actually helped us a lot. Okay, so basically when we started, the legacy network had a few limitations. There was an ARP responder component, so which was enabled only when L3 was enabled. So our activity started with making the ARP responder as default. And then there were some problems in flow entries not getting cleaned up. So, and then there was some unwanted broadcast to all OpenStack nodes. So such bugs were reported and we fixed them. So this is where the initial activities. And then, okay, so this is the key activity. So we had the 3-node job running, but for some reason, whenever the ODL had a failover, we had the 3-node jobs failing regularly. So this was a long-running investigation for these bug reports. So at the end of it, what we identified was there was a lot of notifications from OVS that was being handled. So this fix enabled us to have a stable 3-node job for the legacy network. So these were the fix that was done. So the OVS was restricted to send all notifications, and the read operations for every notification received was restricted. So by this way we were able to stabilize the 3-node job. Okay, this is the okay, so this was an enhancement activity. So there was no reconciliation supported with the OVSDB. So whenever the OVSDB goes down and connects back, so there was no reconciliation synchronization between ODL and the OVS device. So we added support for such reconciliation whenever there is a connection flip-flop. So this was another enhancement that we added. Okay, coming to security groups. Okay, security network had a security group implementation using flow entries. But there were some problems, some parity that we identified when we tested with pure OpenStack, that is without ODL. We had some testing for security groups, and we identified a few gaps where network was basically enabling all communication for all VMs by default, so that had to be restricted. So we created bug reports, and we have tried to come close to what OpenStack does in security groups, but maybe there needs to be some more improvement done. But we have right now, for the identified scenarios, we have done some fix where the current legacy network implementation is able to mimic what OpenStack does. So actually this patch is right now in review stage, so we are targeting it to be released for Boron SR1. Okay, so this is the other use case which we are talking about. So so this is basically a okay, this is basically a seamless L2 connectivity use case. So this component that we are talking about, the VXLAN gateway, it is similar to the L2 gateway component in OpenStack. So when we tried this particular use case with the legacy network, we had a certain restriction. As you can see, the restriction, the ARP reply from the VM was getting dropped. So to solve this, we had to, we actually created a bug report, and we reported that the unknown unicast had to be learned. So such a fix was done to a legacy network. So this patch will also be available with the Boron SR1. Okay, so this is the use case that you are most interested with. So this is the multiple external networks use case. So here is where we started to see a lot of restrictions, because in this diagram, if you see, the BRINT is the one that L2 networks in OpenStack uses, that is handled by OpenDaylight, whereas BREX is the one that is used for external networks, that is handled by the Neutron L3 agent. So since there is no coordination between them, we had some issues in particularly running this use case. So we had a detailed implementation which actually we added a parameter in configuration in ODL which user can enable to say, if I want to use multiple external networks with ODL and legacy network, he can enable the parameter. So if the parameter is enabled, what we will do is we will create a patch port in BRINT, we will create a patch port in BREX, we will install the appropriate flow entries so that user can now have multiple external networks and use the ODL for L2 and Neutron agent for L3 and basically have this use case running. So this was one of the big developments that was done. So this is also targeted for Boron SR1. It will be available with Boron SR1. So we have a wiki page that explains this particular use case as how it to be deployed and how it can be used. Okay, so the current limitations as we understand is, with the legacy network approach that we have taken, as I already mentioned, we are seeing lesser contributions because of the newer network. So basically it is better to move to new network sooner. And also there are no performance or scale tests currently available to evaluate whether it can scale or what is the performance currently, those capabilities. So such testing also needs to be added. Okay, this was one of the lessons that we had. So whenever we were checking the CSIT jobs and the health of the project, what we don't do is we don't check the health of the dependent projects. For example, we never used to check what is the status of the OVSDB job or the OpenFlow plugin job. There could be some other failure in a dependent project job which will later affect us, or there is some particular test case that we are not actually added to our CSIT that could affect. So our learning is that please check all the dependent projects failures so that there is a problem coming later which you may probably get to notice. Okay, so this is just, this is what we want to discuss, what are the future plans. The future is to evaluate the new network. That will happen sooner after Boron SR1. And basically participate in more CSIT contribution to add more test to performance, scalability and longevity for OpenStack integration. So these are our activities. So if you have any questions, you can take it up right now.
Once you go to the new network, you still need OpenDaylight for certain features and orchestration.
Will you still require OpenStack, right? I mean, your question is, once you move to new network, will you still require OpenStacks?
For the underlying.
I didn't get the question because both network is OpenDaylight, right? Sorry if yeah. So we basically have a demo video of that multiple external networks case. So if you would like, we can play it out. Yeah. Sure. Would you? Yeah, you can play the multiple external networks. Yeah. Okay, so this is a patch that is not yet merged. So here we have that particular attribute enabled. So we're just trying to indicate. So it's a demo with OpenStack. So basically from the demo, you don't get what is working, whether it is the OpenStack working or it's ODL working. Okay, so here is where we have tried to indicate that we are enabling the L3 service in OpenStack and we are having configuration for OpenDaylight for L2. And this is where we are creating all the external network and router in OpenStack. So creating network subnets for internal networks. Probably. Okay. I think we are creating instances in both the networks and we are associating floating IP. So now this is a display of trying to access the external network now. Okay, so this is the part where we have access the external network from the VM instance after associating the floating IP. So basically I can drag to the point where we had the network diagram. Yeah. Yeah, so this is the thing that we achieved out of here. So we have multiple external networks that are interacting with the VM instances that are created in OpenStack. So we have a similar presentation for security groups also, where we have tried to demo what was available in Beryllium and what has been done. So So, yeah, I think this shows beryllium. Yeah. Okay, so this indicates beryllium, so it is using beryllium. So here I think we are trying to display what was the shortcoming in beryllium. So basically, even without security rules, beryllium was allowing the legacy network implementation in beryllium was allowing access between VM instances, allowing to SSH and everything. So that is what is shown in the first step. So now there are no security rules which are allowed. So basically, it is supposed to block all this. So later on, I think with the recent release, now we have added all this support where only after adding security rules, we the new legacy network implementation will allow the VM to ping and other communication will be enabled. So without security rules now, all the communication from the VM instances are currently blocked. So I think they added a security rule to allow ICMP and they added a security rule to allow SSH. So I think they are demoing both the protocols here. I think later on we will be playing all this demo in the demo theater also, so you're all welcome. So there will be some more presentations on this topic in demo theater today and tomorrow. So thank you. So that's all I have, unless you have any questions.
IT and network solution provider, and we have been actively working in the SDN field from the very beginning, and we released the world's first OpenFlow product, OpenFlow controller and OpenFlow switch in 2011. And since then, we've delivered our SDN-based systems to over 600 customers all over the world. And as a founding member of the OpenDaylight project, we also have been actively working and contributing to the OpenDaylight community. So as a many open source softwares. So one target use case of our solution is IaaS Platform, Infrastructure as a Service. And the current supported model of our solution is based on OpenStack, and it uses network manager available by default in OpenStack, which is OVS agent. And I mean that our solution doesn't use any SDN controllers yet. So here, okay, so hi everyone, I'm Hideyuki Tai from NEC. Today, our presentation talks about our learnings from ongoing activities to build a high available IaaS platform based on OpenStack using OpenDaylight. So since the last year, we are working towards integrating OpenDaylight into our OpenStack-based solution. So today, we would like to explain about our activities to achieve this integration goal and also share some learnings from these activities in this presentation. So this is the agenda today. First of all, I would like to explain the background of our activities. And then we are going to give you some learnings from our activities with the results of our investigation, design, and development in this presentation. And finally, we would like to also discuss about the future direction of our activities, as well as the direction of the OpenDaylight project. So first, let me introduce ourselves. I'm from NEC, And NEC is as a solution provider, we provide OpenStack-based cloud infrastructure solution. We call this service as NEC Cloud System. So this is a service which offers complete support for every aspect of cloud infrastructure, designing, building, and operating the cloud infrastructure. So based on customer requirements, we build cloud infrastructure based on OpenStack, as well as